Hello friends, so here on a Nucleo 144 you can see LED is blinking, but this LED is not blinking by its own, but here we are giving input from the button. So you can see when I release the switch, LED is not blinking, but when I press it, LED is blinking. Okay, and this is what we will see in today's video. So we will interface push button with Nucleo 144 board, and for that we are using onboard button, onboard LED. Let's start configuration part. So first of all, you have to remember this. On our Nucleo 144 board, one LED is onboard LED is there, and to blink the LED we have to configure it as a GPIO output. Along with this, we have onboard button interface with PC13. Okay, and this time board will listen. Okay, so whatever you will give it as an input, board will listen and work accordingly. So that's why you have to configure this PB13 as an input, and this is the main thing in today's lecture. So till now we have set everything as GPIO output, because ultimately LEDs or output devices are there where board writes something, but this time board will read something. Okay, and now you have to generate the code. Now, before writing this code, you have to understand the mechanism of this switch for this Nucleo 144 board. So here in this diagram, you can see the connections are like this: 3.3 volt connected via the button, okay, and one wire PC13. This is the microcontroller's pin, okay, and along with this, one resistor is connected with ground. So it's just consider like when button is not pressed, okay, this circuit is open from 3.3 to PC13, and that's why on PC13 you will have zero signal, or you can say reset. But when you press the switch, press the button, 3.3 will be connected with this PC13, okay, with this pull down resistor via ground. So now circuit is complete, and that's why on PC13 you will have high voltage 3.3, or you can say set volt. So this is what we have to measure via coding. So whenever user press the switch, okay, we will have high signal, and we will blink the LED only and only when we have high signal on PC13. Okay, so let us start coding. So first of all, this is while one loop. Okay, so first of all, let us write function to toggle the LED, and this we have already done many times, right? I'm not repeating it. Quickly, I will simply write function HAL GPIO toggle pin, GPIO B, GPIO pin 7. Okay, and then that's it. So this will blink LED without any delay, because we have not added any delay. Okay, now as per our coding, we have to toggle the pin only and only when someone press the switch. Okay, and for that, instead of GPIO write, we have to use GPIO read. Okay, so for that, let us write function GPIO read pin. Okay, and again this is also part of HAL, so you have to write HAL read pin. Okay, and which pin we will going to read? The GPIO C, definitely, and port C and pin number 13. Okay, so I'm just sorry, here I have to write GPIO 13. So we have to write this in a loop, that if this is equal to high, or we can say GPIO pin set, right? So when user press the switch, we have to toggle the LED. That's it. Okay, But here one more thing we have to add. Let us say user will press the switch and keep it as it is in pressed condition. Then we have to consider each press separate, right? Because if user will press one time without delay, it will consider as a multiple time. That is called debounce, key debounce, right? And for that we have to add small delay over here. So once if user will press the switch, after 200 millisecond only this logic will read that switch again. Okay, so up to that 200 millisecond it will not read it again, so it will consider as a one press. So let us add very small delay, 200. Okay, that's it. So this is the code. Now we will debug the code and we will load it on our board. You can see the board. Now I'm just loading this. You can see code is loading right now. And that's it. Now I will just press this switch one time. You can see LED is on again. So this is actually toggling the switch, right? You can see on, off, right? And if I will, keep it in this pressed condition, what happened after 200 milliseconds? Again, it is reading this status, and if status is still set, it will toggling this LED. So you can see this is the LED blinking with interval of 200 milliseconds. But this is how your controller will read this switch or read the push button. Okay, so this is what for this video. And remember, this whole logic is based on polling, right? Because your code is continuously checking the pin status. Okay, but here we are not considered any interrupt. So your logic or your board will be busy in checking the status. So this is what for this video. Thank you very much.